Alrighty, we got a few people probably coming in still, but we're going to go ahead and start here. My name is Jason Birch. I'm with ThingLogix, and I'm going to give you a quick overview of our company, and then I'm going to hand it off to one of our hardware partners, D6 Labs, Steve Montgomery. So ThingLogix has deep cloud roots in Salesforce.com for about 10 years now as consultants, and we've been in the IoT, what we call M2M, a couple years ago space for about 6 years now with a company called Telemetry, which was acquired by Amazon earlier this year, and last week they announced their new AWS IoT platform, which is essentially telemetry that we spent 3 to 4 years building. So we have a very good handle on high scalability, guaranteed delivery of messaging, how we also get IoT into a business context. So that's where ThingLogix comes in. We're not an engineering platform, we're really more of a consulting company. We help people roadmap, how am I going to monetize, how am I going to deploy, does this make sense for my business? So we're going to talk a little bit about Amazon Web Services as well as Salesforce.com because we do have so much background with those two companies, important partnerships for us. And again, we're talking about business context, IoT in the real world, not just a dashboard where I can send a message from my phone and see a little graph. So that's kind of the high level background. I'm going to go ahead and hand it over to Steve, and then I'll tell you guys more about cloud in a minute.
Good morning, am I on? Okay. My name is Steve Montgomery. I am the founder and CEO of Digital6 Labs. I'm also the creator of a technology called WhiskerlO, and we are an IoT connectivity company. Our business is connecting things to the cloud, so we're responsible, we take ownership of the connectivity piece from the cloud to the device, where ThingLogix really does the business intelligence, analytics, and business case piece that goes from the cloud to the customer. Connecting devices to the cloud is not as easy as it may seem. You hear a lot of talk about creating solutions around Wi-Fi and cellular and Bluetooth. And the problem with those solutions is that either they're too short range, they come with a monthly cost, or the battery life is terrible. And in the case of Bluetooth, it's the only real technology that has good battery life, but the range is relatively short. And in a lot of applications, actually most IoT applications, where the things are that you want to collect the data from. Last week we demonstrated a connected hand soap dispenser at the Amazon event, for example. In the bathrooms in an airport, there's no Wi-Fi and there's no power. So even if we were able to install access points outside all the bathrooms in an airport, we'd still be changing batteries in 47 or 68 devices every 6 months. Our technology, WhiskerlO, is based on the LoRa radio technology from Semtech. You guys probably saw the booth that they had in the exhibitor space. It is a complete solution platform. We don't just make a component. We're not just a module vendor. We have a commercial gateway. It's Linux-based. This gateway is capable of pushing data to any number of REST-based or MQTT-based third-party APIs. That's how we were able to do the connected hand soap dispenser. We have prepackaged wireless sensor end nodes. We call them sensor blocks. Those can be equipped for a number of applications. We have them that do environmental monitoring, process monitoring, so they could do 0 to 5, 0 to 10, 4 to 20. We also have a version of it that can even do water metering, and those are being installed in apartment complexes in Georgia right now. Finally, we have, and this is the heart of our solution, the WhiskerlO Engine. So our solution, like I said, we're responsible for basically everything from the cloud to the device. And our solution is capable of doing environmental process monitoring and connecting you to the cloud. Now here's the cool thing about our stuff though. You don't have to use our gateway if you don't want to. Our module can act like a gateway, and I'm going to demonstrate to you here in a little bit how we took a module and connected it to one of the IoT enabler boards and turned that into a gateway. And that's really important. Because there's going to be times where you don't want to use a prepackaged gateway. Maybe you're a manufacturer of a thermostat and you already have internet connectivity and you just want to reach out and touch wireless humidity and temperature sensors. Well, in that case, you can embed one of our modules in your thermostat and use it as a gateway to push that stuff to the cloud. And like I said, it all starts with the Whisker engine. The Whisker engine is based on LoRa. It gets 4 miles of range, 5 years of battery life off 2 AA batteries. That's what we call direct sensor interface, so there's absolutely no code to write to make this work. It has analog and digital input. It has I/O expansion through the I2C port, and we have drivers for a large number of devices. You can hang external port I/O expanders, A to D converters, and digital sensors off of that I2C port. We also have UART. The module can operate in transparent serial mode if you've got just a basic wireless wire type application, but that UART is also smart. You can put it in a mode where it will pull data in the NMEA strings from GPS and report location. It'll also do Modbus RTU. So if you've got devices out in the field that you need to connect to that are legacy that talk Modbus, this is good. So basically this module could connect to any kind of sensor or legacy device, HVAC, whatever. Like I said, it has multiple modes. It can act the one device with the same firmware, so you've got one SKU. It can act as a gateway, a node, and even a wireless UART. They're FCC approved, and they're very, very small. It's less than 1 inch square. They come in through-hole and surface mount versions, and you can get them populated with the UFL connector on it, like you see here, or we can leave the UFL connector off and you can run a connector off of your PC board. Battery life is really important in the Internet of Things. It's absolutely critical because it's maintenance. If the Internet of Things, I like to say it reminds me a lot of where e-commerce was back in 1995. Everybody knows they need it. Everybody has a program to figure out what it is, but nobody knows what to do with it. And as customers figure this stuff out and they start taking risks on deploying Internet of Things applications, they've got to be low touch and low maintenance. They really need to be fire and forget technology, and that's what we've tried really hard to develop. So battery life was real important. This is the reason why the module was built around the RL78 microcontroller. A lot of people like the Cortex M3 parts, the Cortex M0 parts, RX111 parts, and they're great. But nobody can touch us on battery life. And the only reason that we're claiming 5 years is because that's basically the maximum shelf life of AA batteries. If you run our modules with the 5-minute update interval, they can last for 15 to 20 years off 2 lithium iron disulfide batteries, which is basically the Energizer Ultra Lithium. Which makes it great for applications like AMR too, by the way. This is a basic range test that we did around our building. In this case, our offices are located here. We had the gateway 6 feet off the ground for this test. You can see our best case range was about 1.66 miles, which is pretty good. If you get that gateway up about 15 feet, that would more than triple that range would. And this also is, you'll notice here, we've got a lot of buildings, 4- and 5-story buildings that we were having to push through here. And our worst case range in this urban environment with no line of sight at all was half a mile. So this technology is a venue scale technology. It's not just built to communicate between rooms or between devices. It's built to communicate through hotels, airports, farms. Now, I told you earlier that you can hang sensors off the I2C port. And this is really kind of some of the genius of the module. You can remotely configure the module to do everything you need it to do. We have drivers for temperature, relative humidity, light, UV. We even have a heart rate driver for that sensor. Proximity. We've got, and I'll show you in a minute, our air quality sensor. These are just some examples of the sensors that we support through that port. And basically, they're all assigned channels. And so you can say, for example, the air quality sensor is analog channel 17. You can configure the module to report that channel once a minute, or you can set a window and say if the value goes above this level or below this level, or it stays at this level for a certain period of time, you can set an event trigger, and the device can also initiate a communication based on that. By the way, I don't think I mentioned it, but we've got some data sheets up here and cards, so feel free to come up afterwards and grab those. And we're going to try and get this done fast enough so we can do some Q&A at the end. So what we did for the Renesas show is to show that we can do embedded gateways as well as the Linux-based gateways. This is the demo that I'm going to demonstrate to you here in a little bit. We've created a PMOD adapter board that plugs into the IoT enabler. It also plugs into the S7 DK and SK, and pretty soon, as soon as I can get home and do the work, we're going to make it work with the little round red S7 boards that were available in the exhibition area as well. We also created a development version of our sensors called Sensor Squares. These can be populated with GPS, air quality, temperature, pressure, a whole range of sensors. And we have this package in a kit that you can buy. All of the software we've written, all the hardware and software for this, with the exception of what's in our module, is open source and it's available on GitHub. And I'll give you the address for that in a minute. So I guess we're at a point where we're ready to do the demonstration. When you go through and use the application, I'm sure you guys have probably been through, most of you have been through the provisioning process with one of these IoT enabler boards. Press button 2 on reset to provision the Wi-Fi. The provisioning process is normal. Once you've got it provisioned, you can just reset it and the gateway application will run once you've got our code loaded in. And what the gateway application does is it connects to telemetry via MQTT. It sends a status message every 30 seconds to update the system and let it know that it's alive, its heartbeat. And then it also receives the responses from the various Whisker devices and parses them to pull the channel data out, package it in JSON, and then it sends it to a topic on the telemetry MQTT broker that they then use to drive a dashboard. The PMOD adapter board, the PMOD sockets that are on, our module has a UART interface. We don't have a SPI interface. We ran out of pins. So we have a UART interface. So on the PMOD adapter board, we used an XR SPI to UART converter. The driver is in the example code. It includes the converter, the Whisker engine, and the PMOD connector. Now we also have a version of this adapter board that has USB on it as well. So you can run a cable from the board to your laptop and do your development on a PC or any Raspberry Pi or any device that supports virtual COM ports. The sensor squares are powered by two AAA batteries. Like I said, we have multiple potential sensor configurations. A really cool one is we've got what we call our tracker version that has GPS and accelerometer. And that device you can configure to report when the device is in motion. So it leaves the GPS down. When it detects motion, the GPS comes up and it starts reporting position. You can also tell it to report position every 15 minutes or whatever. Module hardware interface, our UART interface uses 115.2 8N1 regular 3-volt signals. The module can be powered from 2.1 to 3.6 volts. Like I said, we've got analog and digital in, so we've got 2 analog in. These are 0 to 2.5 volt analog inputs, 2 digital in and 2 digital out. I/O expansion through I2C. Let me see. Let me switch over here real quick and I'll show you what one of these sensor squares looks like. It's kind of dark, but so this is a sensor square, for example. And we've got our module, and right up there in the corner, that little white dot up there, that's the temperature relative humidity sensor. Yeah, see if that, turn it on and see if that helps. Yeah, the auto gain is killing us. But it literally is this simple. All this device is, all that's on this board right now is the batteries, the antenna connector, the module, and the sensor. That's how easy it is to build a wireless IoT device with the modules. The modules are commanded via AT commands through the UART. So the UART, when it's not in command mode, acts like a transparent serial transport from one module to another. Every module has a unique 32-bit MAC address that's set at the factory. That's how it's addressed. The modules have those on the front. There's also a little QR code that has that embedded in it, so it makes it easy for a configuration. When you create a gateway, the gateway is typically the only device that sends AT commands. It can command the local module through the UART, and it can also command remote modules via remote AT commands. So you can do things like set a digital output, read an analog input, set a periodic analog input to say I want to read that every minute, or set a window. You can send remote Modbus commands, all of that. That is important because that allows the gateway programmatic access to the entire network, which makes building an IoT system very, very easy. And with the demo code that we provided, it makes it really easy for you guys to get off the ground with that too. The AT commands can set the channel, so you can, there's 3 ways that you can isolate your network from everybody else's. You can operate on a different channel, you can operate with a different spreading factor, and you can use a different encryption key. We use AES 128 encryption for all of our communications. When the encryption is enabled, though, we do have a 16-block limit, so it affects the way the transparent serial works a little bit. You can request readings, change output state, pretty much anything. Datasheet is available on our website. You don't have to log in, or you don't have to register to get access to any of our data. Our data is all freely available. For provisioning, every module, like I said, has a unique 32-bit MAC. When there are 2 commands that are used to connect a module to a gateway. The ATTM command is set target MAC address, and basically on the gateway you would send that command with the MAC address for the module you want to talk to. Then you send the ATMA command, that pushes that out to that module, and now that module knows that this is the gateway. Modules can communicate in a peer-to-peer environment. If one module requests something from another module, the response will go to the requesting module. When you set up things like triggers and periodic sampling, though, you're going to have unsolicited messages. The ATMA command tells a module where those unsolicited messages go, which would traditionally be to the gateway. And I don't really know what that last line is there for. Oh, yes, I do. Updates. So updates are the unsolicited messages that I was talking about. Digital and analog I/O, we have 4 tables. It's actually very similar to the way that Modbus works, except that we have defined the channel numbers. We have 4 channels: analog in, analog out, digital in, digital out. And they're all addressed by channel number. You can set state triggers on any of the digital inputs, window triggers for analog in. Those will create event-driven messages. When you go from a periodic sampling to event-driven sampling, the modules get very, very low power. They definitely will operate to the shelf life of the battery. You can also set up periodic sampling for up to 4 input channels. And this is pretty cool because a lot of our competitors in the space will give you one, maybe 2 channels per device out in the field. Well, you can set up triggers on as many channels as you want, and you can have periodic sampling on up to 4, which gets you a lot of scale. You can put a lot of value in one device. And I'll tell you how we use that. Say you've got a convenience store owner, and he wants to monitor temperature and relative humidity, or temperature in his in the freezers in his store. Well, he could take one of these. He doesn't even have to buy one of our modules. He can just buy this off the shelf. By the way, we have a partner program where we'll actually white label these things. We have a nice wall bracket that works with them. But he could put this in his device to monitor temperature, but it also has 2 analog input or 2 digital inputs, an extra analog input and a digital output. So we can monitor 2 doors to know if they're open, for example. We could control a light remotely. We could also connect a remote temperature probe if he wanted to connect it to another device. So with this one device, he can monitor multiple inputs. And that we found that's a very strong value add that we provide that customers like. The module, when you send an AT command out, you will get responses back. There's local responses and remote responses. Local response is usually either going to be OK or error. The remote response also can indicate OK or error. So if you send a command that's improperly formatted and the module can't do what you're asking it to do, it'll send an error. That makes it really easy in your application layer to say, okay, there was obviously a problem configuring that. I could push that up to the user and let them know that I can't do what it was that they were asking me to do. The remote module for this demonstration, the only responses that we're getting from the modules, the way we have them configured, is we're getting a response update message, which is an RMPU message, and I'll go through that. Actually, here it is right here. That's an example RMPU message. When you get a response, every response that starts with RM is coming from another module. The next two letters will tell you what kind of response it is. So if you sent out an ATRA command to read an analog input, the response would be RMRA, for example. In this case, because it's an unsolicited response, meaning the module generated it on its own, the response actually has the MAC address embedded into the message so that we know where it came from. The way this message breaks down is the first four letters tell you what you're getting. The next two are in hex. All of this is hex. They tell you how many bytes are in the actual payload. You get the MAC address, and then the channel data starts coming in. The channels are specified by 1 byte. The lower 5 bits are used to indicate the channel. The upper 3 bits are flags that determine what kind of channel it is. So in this case, a 43 indicates that it's an analog input. 23 would be a digital input, for example, channel 3. Analog inputs are always measured in 16-bit numbers, and in this case, we're getting 142, which converts analog input 43, by the way, is the battery voltage. So if you convert that to hex, you get 322. It's fixed point, which gives you 3.22 volts. The last two letters the last 2 digits in the message are the RSSI. This is pretty critical too. We use this all the time when we have customers install stuff out in the field because that gives us an idea of the kind of range performance that we're getting and the signal quality that's coming along with it. Okay, let me see if I can get this switched over here. He taped all these buttons up but one so I wouldn't press the wrong one. And I'm probably still going to press the wrong one. There we go. Okay, so GitHub/D6Labs/IoT Enabler. That's where all of the code and the sample schematics and PC board layouts are for the boards. Let me switch over here. This is actually a really quick demo. Foundry is and I'll let Jason talk to Foundry, but this is really a slick platform that they've created for allowing us to connect to Amazon. One of the things that he'll talk about is the new Amazon platform is super powerful. It's also ultra secure, but man, it is tough to connect to. It requires SSL and a bunch of other things. These guys have created tools that allow microcontrollers to push into that. They basically act like a proxy for us so that we don't have to do all the SSL stuff with our microcontrollers. And what they're doing is they're actually taking those RMPU messages. Well, we're taking the RMPU messages, parsing them, sending them to the MQTT broker in JSON, and then they're using it to update this very simple dashboard. Now this is the actual, and I'm sorry if I make anybody sick with this fast. I'm going to scroll through this, but I forgot to preset this where I wanted to be. So this is the code that is running in the gateway application now, and it's really simple. It makes the connection to the internet through the Wi-Fi device. It connects to the MQTT broker, and then it runs in a big loop, waiting for characters to come in from the SPI port. And once as characters come in, it cycles through this loop. When it finds the RMPU command or the RMPU at the beginning, it waits until it gets enough characters, and then it comes down and parses it. So it pulls the MAC address out, the length string out, and that's what we're doing right here. It uses, we've got the function find module. There's a list, a predefined list of modules that are set in this application. You could easily make that data-driven from an SD card as well. Right now, they're hard-coded in memory. But the find the find module function is where you would change that up. It looks for the MAC address in there. If it finds it, then we go ahead and go down and parse the the message. And so this is where you can see we're going through and we're looking at all of the variations for input types. And this is where we're adding so if we've got digital input 2, for example, then we know that that's DN2 on the module. We add that to the MQTT code. Once we've parsed all of the channels out and gotten all of the data, we finally get down to here. Whoops. And that's where we, this right here is where we, line 567 is where we push it out to the broker. And so it's real simple. All you have to do, there's two things you have to do with the MQTT broker. The publish topic and publish message, if you guys aren't used to MQTT, it's a publish subscribe protocol. The topics determine where the data is going and who's going to, and subscribers, the demo that I showed you earlier is subscribing to that topic, and that's how it gets the data. The message it doesn't have to be JSON, it could be anything. Almost every service you're going to work with is JSON, so that's why we decided to go JSON. So that part is really easy. The other thing you have to do is just continuously monitor to make sure that your MQTT broker stays connected. And there's another piece at the top that does that. So that is the code review. And let me see if I can switch back over. And guys, at the end, we're going to make sure we leave a little bit of time for, well, maybe we're not. Did I use all the time? Okay. We're going to try and leave a little bit of time for questions. So I'm going to give this back over to Jason and let him talk about ThingLogix. I'm sorry for taking the time.
Okay. Some of these I'll roll through kind of fast for the sake of getting to the questions. Just kind of history of cloud computing. You know, there's some major milestones that we've seen. First Apple computer. IBM launches the PC 8 years later or so. And then we start looking at things like the first notebook in '89. Amazon and Facebook, you know, in the early and mid-2000s. Salesforce.com comes shortly after. Then we start getting into mobile phones and Google apps and such. This is what sensors and modules look like to business sponsors. So it's, you know, it's very much, to all of you engineers out there, you know what you're looking at, but to a lot of guys at the C level and in the sales and marketing, it's just a paperweight, right? But this is what it actually represents. We're talking about understanding customer loyalty, real-time engagement, you know, product and customer behaviors, and again, customer loyalty at the end of the day. How do we satisfy their service needs, make sure that they're getting everything that they need? And this is where a lot of hardware companies are looking at services as a new revenue stream, right? You sell a widget, you get $50 one time, and then you wait till you sell the next widget. But if you can begin to monetize a revenue stream, recurring revenue on a monthly basis for some type of a service, whether it's real-time alerting, whether it's predictive maintenance, we can tell you when your module is going to fail before it happens. We can begin to you know, look at benchmarking and is it performing like it should? So really the data becomes very powerful and is worth, you know, money to you guys. If we look at IoT maturity, you know, everybody feels like they're late to the party, but in reality we're still very, very early in this curve. There's a lot of startups that are coming along with new products, trying to get things connected. All of the major, you know, Fortune 100, 500 companies are connecting products. And the kids that are growing up nowadays are going to be born into a world where all the devices are communicating, right? We're talking about alarm clocks going off earlier because it snowed the night before and it knows that traffic is worse and you need to get up 20 minutes before you thought you did. Products that are reordering themselves, like we showed last week at the Amazon event. We've got a soap dispenser that actually ties into the Dash replenishment system, and now it can begin to reorder its own consumables based on usage, and we can predict inventory for people without anybody having to be involved. These machines will start to say, this is how much we're using, this is when we're going to run out, this is when we need to reorder, and that will all take place automatically. I'm going to skip that one. So how did Amazon get into cloud computing? Obviously, they started as a retail bookstore, began shipping millions of products annually. They had a real need to run their e-commerce store, as well as accounts and credit cards and all of the other things that go along with the website. Now you've got Prime for free shipping. You've got Prime Now, which means you can get things delivered within an hour if you live in Seattle or San Francisco. So rather than paying somebody else for data centers, they decided to start building their own. They've released 1,100 something new services, and what's really interesting is 47 price reductions. So the cost of this stuff just keeps going down. There's no reason that you would want to have an on-prem data solution unless you're worried about security. You know, there are a few use cases where that makes sense, but for most people out there, paying for what you're using makes a lot of sense. And we're getting down to pennies per gigabyte nowadays. The other major cloud power out there that I want to talk about is Salesforce.com. Most of your guys' companies are probably using them as a CRM to manage opportunities, track and forecast sales. This can also be used to open tickets and cases for technicians. And one of the things that our system does is it ties device data into Salesforce so that if we start to see that a device in the field is having an issue, we can actually route a maintenance guy automatically to the location. And it's not like the old days where he had to go out there just to find out that it was broken and then figure out what parts he needs and then come back and order them 2 weeks later. Now we can send him knowing what's wrong with it, with appropriate tools, with the appropriate replacement parts. And it's just much more efficient. And again, it all ties back to that customer service. So Mark Benioff, CEO of Salesforce, has this concept that behind every connected device, there's a customer. So, you know, down the chain, connected employees, connected service, connected sales, marketing, and products. This is kind of high-level application flow. The devices, as Steve talked about earlier, are sending over MQTT or HTTP. We have secure transport for both types of protocol into a broker, which is going to take a look at these messages. It's going to evaluate against rules that are set. And in a rule, you can say, I want to push that to a dashboard. I want to push it to a Lambda function. I want to send something to Salesforce, send me an SMS, an email, whatever it's going to be. So very, very powerful rules engine. From there, you know, again, the business context. We can send it into a CRM, a human resources application, something else on the back end, or we can send it to a UI on a mobile phone, open a case, whatever it's going to be. Last week, you know, Amazon Web Services announced the new IoT platform again, which was built on telemetry, that we sold them in March. The reason that I think this is so important is what Steve hit on earlier. These guys did not make it easy for devices to connect to the platform. It's a very, very powerful platform, but you've got to have a certificate that lives on the device. You've got to deal with all kind. I mean, they put security first, which is great, but some devices don't even have enough memory to hold the data that's required. So one of the services that ThingLogix and Foundry offers is a proxy broker that adds those layers of security for you. So we have an MQTT broker. You send your message. We tack on a certificate and some additional authentication. Then we push it forward onto Amazon for you, where then all of the really powerful stuff can happen. So Foundry is basically this little stack that you see here on the left. We have an asset manager, which helps you keep track of things, all the metadata, location, where is the device. Orchestration is basically how we tie into things like Salesforce and Amazon ServiceMax, other back-end systems. We've got a meter manager, which allows you to see how much your devices are costing you in cloud compute. So, and we're not talking about average, we're talking about give me the top 10 most expensive devices, right? And then you can begin to look at why are these running so much more than average or than all of the rest. Proximity manager is a Bluetooth or a near field type of technology where we can begin to triangulate in a warehouse to see where things are. We can also walk up to we can walk into a room with our mobile phone and see that there's 4 devices in this room and begin pulling historical maintenance records or how-to tutorials to fix things. So based on that BLE, we can begin to pull data just being in proximity to a unit. So this is kind of the big picture, WhiskerlO to MQTT broker. From there, we can evaluate rules. We can send it to a database. We can do Lambda type functions, push data into Salesforce, and at the end of the day, deliver some type of an enterprise solution. We do also have, dashboards. I kind of made a joke at the beginning that IoT is not really just about dashboards, but these really are great for debugging. When you're trying to figure out what's going on with a device and you want to see some real-time data coming in, what's going on with it, right? I want to get in there. I want to see what's been happening. So this can be a powerful tool in that regard. Customer use case, sealed air. These guys are most famous for making bubble wrap. They invented this packaging material that we've all seen many times, but they've also moved into cleaning supplies. And with a connected soap dispenser, they were able to put these in restrooms around hotels, conference centers, warehouses, to begin to determine which restrooms needed to be cleaned. Rather than having to round robin the cleaning crew every 20 minutes, we can say, hey, this bathroom's had 100 people through it. This one over here hasn't had anybody. So based on a simple push of soap, we can tell if the waste bin needs to be emptied, if the toilet paper needs to be replenished, and all this other sort of data that started to come out of that. And then they started thinking about compliance. Now we can actually determine if employees at a deli are washing their hands each time that they're going to the restroom. So some really big and powerful concepts came out of this as we begin to look at the big picture. One more thing. Echo. So I don't know if you guys have this. Some of you may have it in your home. This is Amazon's tool into home automation. So you'll be able to say, turn on lights. I actually have this in my house connected to my Nest thermostat, and I can say, set the temperature to 72, and it does it. And there's all kinds of cool things that are going to come out of this because of Amazon's presence in the retail space. They'll be able to ship you a coffee maker that's already connected to your Wi-Fi, a vacuum that's already connected to your Wi-Fi. You just turn it on and everything starts talking to each other. So we've gone ahead and wrote an Alexa skill where you can ask this thing, Foundry, tell me how much battery is left on my whatever, or tell me what's the fuel level of my XYZ. So it's kind of gimmicky, but it's kind of cool also. And I think it's going to be a big play in the future of home automation. All right, I think we have about 15 minutes left, so good for questions. Here's the contact info. If any of you guys have projects that you're looking at, you're not sure how to deploy, monetize, doesn't make sense, we need some functionality on the back end, we need an iOS, an Android, a web app. Those are all the things that ThingLogix can help you do. So please feel free to reach out.
Anybody got any questions?
Yes, Steve, have you done any experiments with energy harvesting?
You know, it's funny, I've had that energy harvesting question about 6 times here, and it's the first time people have really talked to me about it, so I could tell you guys are really interested in that. The short answer is we've thought a lot about it, but we haven't had a real application. You know, our business is about, in the IoT space right now, 99% of what you see is proof of concept. We have been focusing on proof of scalability, and so real applications have been our focus, and we just haven't had one come across our desk yet. Our technology is ripe for it, though. Our maximum power consumption is 140 milliamps, so you can do that with a supercap. Our sleep current is measured in nanoamps, so you know it's very conducive to that. But we have not done any experimentation, no.
Thank you.
Anyone else? Of the module? Yeah, so I'm sorry, you did ask me to repeat the questions back there. What is the price range of the module? This is another one I get asked a lot. The quantity one pricing is $29, but in thousands piece quantities we're pushing you know, in the $16 range. Our goal within 12 months is to try and be closer to $10. A lot of that's going to be determined by Simtech. The LoRa technology is amazing. I mean, it is truly an enabling technology for the IoT space. Before LoRa, there was nothing that could do what it does. I've been in embedded RF and wireless for almost 25 years. But they own the market, and they know it. So we got to wait for them to bring the prices down. And all of you guys can call them and ask them to do that, and that'll help us get that cost down. I'm sorry.
Range testing, how high were your sensors?
I'm sorry?
What was the height of the sensors in your range test figures you showed?
They were sitting on the bed of my truck. So it wasn't very sophisticated, other than I was grabbing GPS points.
What kind of antennas?
We use half-wave, the half-wave dipole antennas. Ours aren't, the antennas we use have 4.3 dBi gain, so they're not the full 6 dB that you can get, so there's still a little more range. But that mostly has to do with size. On our bigger products, we can use a more traditional quarter wave antenna, but with 900 megahertz, as you shrink the device down, the ground counterpoise available is smaller, so you need a balanced antenna. That's why we went with the half-wave dipole. Now, in the hand soap dispenser application, we used a little strip antenna, peel and stick antenna from Murata, and the range on that is about half of what you get with the half-wave dipole. But yeah, if you guys have, we've done a ton of range testing, so I can give you all kinds of data on different antennas.
What kind of environmental enclosures do you offer?
For our devices, so we have, we call this our commercial sensor block. We actually have so many variations of this stuff. We've got a gateway that it's in an outdoor IP68, enclosures for pole mounting. We also have a version of this that's in a metal enclosure, IP68. You can drive a truck over it. That one is set up for process. So it's got 0 to 5, 0 to 10, 4 to 20 milliamp input. It's also got, it has the A to D converter already on it, so it's got multiple channels. For RS, we have a version with RS-45 converter, so we can do Modbus, RTU, all that kind of stuff.
Modbus master?
Yeah.
Can you be the master?
Yeah, that's what we are, is the master. Yeah. There's not, because of the way the sensor works, there's not a lot of value in us being the slave unless the slave was the gateway. And I haven't come across a use case yet where that would be valuable. Usually what people want to do is they've got a pump jack controller out in the oil field and it has the card data setting off in one of the holding registers and they want to go out and read it. And so that's what, it's master slave.
Question over here.
Yeah, Jason, what's your relationship with Web Labs? I think I noticed that on your initial slides.
Yeah, actually, there is no relation there. That was one of Steve's slides, that he can work with any cloud, just as we can work with any hardware. Sort of hardware agnostic, cloud agnostic, if you will. Yeah. Now,
I'll comment on that, guys. We work with Exosite and Bug Labs, and we're about to work with ThingLogix. There's a lot of cloud solutions that can create pretty dashboards, and dashboards are critical. They give you a snapshot of what's going on at any given time. But if you don't have rules, Lambda functions, you don't have critical business intelligence and analytics, it's not going to be useful to the customer. And that's where, you know, as device manufacturers, that's what we have to think about. You can't take the cloud piece for granted. There's a lot of cloud guys who take the device piece for granted, and all of us know that's not easy, right? But the cloud piece is hard, and that's why this Amazon announcement was so exciting, because these guys have built a bulletproof, scalable system that is really going to allow the devices that we build to send tons of data and provide customers with just an amazing bevy of, and I encourage you, actually, you can search Amazon reInvent, and there's a colon between the re and the invent, and the CTO's keynote, there's 2 videos on there. The CTO's keynote, he talks about the IoT platform because they announced it there, and it's absolutely amazing. The downside, like Jason said, and I mentioned earlier, is that it's all SSL based, and so if you've got an 8-bit microcontroller, you're going to be out of luck. But that's where Foundry comes in. They have a whole certificate manager process, and you can use them as a proxy to get into Amazon, and you know, it's very, very beneficial.
Quick question. To deal with the issue of the certificate, wouldn't you put that in a gateway? I mean, isn't that what it belongs, basically? You collect all your data, and then you come to the right promise, and you put your certificate in a gateway.
Yeah, you do. So if your gateway's got Linux or Windows or something like that, it's very doable. But like, I'll give you a perfect example. We're going to announce a new gateway in probably about 8 weeks. We call our micro Wi-Fi gateway, and all it is our module and a Wi-Fi module tied together. We're going to sell them for $80. It's running on a 16-bit micro. There's absolutely no way I can get
Wi-Fi with enterprise security. You're done.
Well, no, well, okay, but if you do that, you're going to pay $30 a module. If you want the $8 module, you don't get SSL.
That's true.
Okay, so that's the trick, right? This is where it's hard, because they aren't putting a big enough processor on their module to store the SSL code. The Micrium guys were in their booth also at the AWS event, and the guy who did that demo was telling me that they were running on the RX63, and he said the code went from, their demo code for doing this IoT stuff went from 26K to 150 something K, just adding the SSL libraries to get the connectivity to work. And so it's, you know, it's a per unit cost thing. Any more questions?
General question, what's about cloud computing, what's the I guess, difference between the old way of computing where everything was just kind of on servers and data centers and cloud computing? And it seems like a lot of this stuff has been around already for a while, but now there's a term for it, and I was just wondering.
Yeah, I mean, the term may be new. You're right, to the technology's not new. I mean, there's still hardware somewhere, right? The difference is capital costs. Like, you know, back in the day, you had to buy a server and you had to put it in your house, and you had to worry about redundancy. Frankly, you had to put everything on a backup disk and take it home at night in case the building burned down, right? So now you're only paying for what you're using. You can run these functions that take a micro, you know, a half a second or less, and you only pay for that little snapshot. You don't have to buy anything up front. Not to mention, we can store it in multiple locations around the world. So if we're sending data to Virginia and Oregon at the same time, and we see an outage in Virginia, we're still up and running, and we haven't lost anything. So I think, to your point, you know, cloud is maybe new, but there's a lot of benefits there.
Yeah, so let me give you an example, right? In 2008, I designed an oil field monitoring system. We called it M2M back then, but it was basically what Internet of Things is today. We had our own server, we ran it in IIS, and it was a gigantic pain in the rear end, guaranteeing availability and uptime. And if we had a serious concern with, as we were adding devices, how much load was it going to take? Well, now our server is setting up in I probably shouldn't say this because of how hard we've been pushing Amazon, but I use Azure for my stuff. And in Azure, we've got our own little portal that customers can use with our devices, and it's great for debug. And in Azure, all I've got to do as I add devices is I can increase VMs, I can increase instances, I can replicate an East Coast, a West Coast, a North, and a South. All the data is automatically backed up. That stuff is so mixed up in that sea of servers that nobody it's gonna be very difficult for someone to go in and pull that data out unless they have my security passwords, because there's no one computer that all that data sits on. And so that's really the advantage of the cloud, is the scalability, the replication, and the security. And man, it's just easy to use. It's like you want 3 more servers, you slide a slider right, pull out your wallet to pay for it, and you're good to go.
From a developer standpoint, it also adds, another layer of abstraction where you don't have to care.
Yeah, the IT is.
Just send the information to the cloud, take care of it.
Yeah, your IT support, and actually, didn't you have a slide that
Yeah,
talked
yeah,
about how
there-
it pushes the IT, takes the IT away? Are we out of time?
There was a
Okay.
slide I kind of glazed over, but yeah, to your point, it's, back in the day, you went to your IT guy and said, hey, I need this, and he kind of went, oh gosh, what a headache, I don't know if that's possible. Well, now you can just go online and do it yourself, so it's very easy to use. And the costs are so low, it's unbelievable. I mean, the 47 price reductions over the last decade, that's just going to keep going down, and eventually it's going to be free, pop-up ad or something, but
Yeah, I think we got time for one more.
You indicated you're FCC and CE certified. Is that a?
We're FCC certified, we don't have CE yet.
Ah, CE, okay. One of your-
CE is filing, right? So we've already got the testing, we have the test data, all we've got to do is the filing.
Is that a usable certification for, if I buy your module to put it on my own board?
Then you would inherit my FCC. It's a limited modular certification. So basically, there's a statement you would have to put in your manual. There's a sticker you'd have to put on your product with the FCC ID, and that's it.
How many antennas do you certify with? This antenna, you had to do part certification if I change the antenna.
Yeah, well, you have to do it with the various antenna gains, and so we went with the maximum one. So anything underneath it,
You're still okay.
yeah, is okay. Now, if you want to do PCB trace antennas, then you're probably going to need to get your own. You're going to need to get some testing done to validate that you're not putting harmonics out into the air. Do we have? We probably got time for one more small one if anybody's got one. Okay, guys, thanks.
Okay,
Thank
thanks
you
for
very
coming.
much.